Going to have a quick look at a DC electric motor. It consists of an armature on an axle. It has a split ring commutator at one end, and that is placed within a magnetic field. Now all the armature is a coil of wire, which when it's connected to an electrical circuit will have a current flowing around that wire. Now that conductor will be placed in the magnetic field, and each side of the conductor will experience a force. One side will be up, one side will be down. Because they're a distance from the pivot or the axle, that'll produce a turning effect. That turning effect will continue to exist, but will get less and less the more and more vertical this armature goes in its rotation. As it rotates, you'll notice the brushes are always in contact and you've always got the forces in the same direction. If it got to vertical, the brushes would no longer be in contact with the armature and you'd actually get zero turning effect. So what happens in this case here is that the inertia of the armature will make it pass beyond that vertical point. And when it passes beyond that vertical point, the brushes will now connect to the opposite side of the commutator. This means that the current will now flow in the opposite direction around the coil. This means that the side of the coil that was initially experiencing an upward force will now experience a downward force, and the side that was initially experiencing a downward force will now experience an upward force. However, the torque will still be in the same direction. So while the torque is always in the same direction for the armature, it will be maximum when the armature is parallel to the magnetic field and minimum when it approaches vertical.